2025, May, June, paper 31. Okay, so let's take a look at question number 1. A particle P of mass 8 kg is moving in a straight line at time t second. P has a displacement of x meter from a fixed point O on the line and velocity v meter per second. The only horizontal force acting on P has a magnitude of x cubed plus 4x Newton and x in the directions of OP. When t equal to 0, x equal to 0, and v equal to 1. Find the expressions of v in terms of x, giving your answer in the form of v equal to the as squared plus b, where a and b are constants to be determined. So what you need to do over here is that if you resolve the forces horizontally, you get the force is equal to the ma. So the only force that acting on this direction is actually x cubed plus the 4x Newton as given. The mass is 8 kg, so this is your A. So your A, it will be equal to the x cubed plus the 4x over 8. Then A, we can write it as a v dv dx, because the expressions for the force given is in terms of x. So we will write v dv dx, and provided they want you to give the answer of v in terms of x. Okay, so now what you need to do is just need to do the separable variables. 8 dv integrate is equal to the x cubed plus the 4x dx. So if you integrate this, you get a 4v squared equals to the x power 4 over 4 plus the 2x squared plus a c. Okay, so now we need to find a constant c based on the informations over here. So given when x equal to 0, the v is equal to 1. So we have a 4 is equal to the 0 plus 0 plus c. That means the c is a 4. Okay, so now what you need to do is replace the c equal to the 4 inside here, then you will get this. So since we want v in terms of x, so we will just divide the 4 goals over here, make everyone become a fraction, one fraction. So this one is over 16. This one, it will be 8x squared plus the 16. Okay, so now we just need to factorize it. You can see that this actually can be factorized as x squared plus the 4. This one is a 4, and then you have a square. So your v is supposed to be equal to the plus minus of x squared plus 4 over 4. Okay. However, we need to say that v is equal to the x squared over 4 plus 1 because of the x equals to the 0, v is equal to 1. Because in order to fulfill this condition, then you need to write the v is equal to the positive of x squared over 4 plus 1. So done. This will be the answer for number 1a. Now we move on to the number 1b. Find the expressions for x in terms of t. So now we are looking for the displacement in terms of t. So based on the result that we have obtained earlier in the part A, so we change it become dx dt. Over here, I think we will need to combine them together, become one fractions. Then this one, it will be 4 x squared plus 4 dx, and then integrate. This one is integrated dt. Okay, so this one is a formula booklet. This one is uptangent. So it's a 4 multiply half uptangent of x over 2 is equal to the d plus d. Then this one is a 2 uptangent of x over 2 equal to the d plus d. Then given, check back the initial value. When the t equal to 0, x is equal to 0. Okay, so given when t equal to 0, x equal to 0, so it will be 2 uptangent of a 0 equal to the 0 plus d. that will give you D is a 0. Okay. So now what you need to do is actually the 2 tangent of x over 2 is equal to the t. But we are looking for x in terms of t. So it will be x is equal to the 2 tangent of t over 2. Okay, done. This will be the answer for the number 1b. Okay, so now we move on. We have a question number 2 over here. 24 meter per second at an angle theta degree above the horizontal from a point O on the horizontal plane and move freely under gravity. At a horizontal distance of 35 meter from O, there is a vertical wall of the height 10 meter, which is perpendicular to the vertical plane of motions of P. Determine the value of theta for which the P just clear the wall. Okay, so that means if you draw it out, okay, this is the point O. And this is the project. This is the point that you project with the u equal to 34 meter per second at an angle theta, and it's just clear the wall. Okay, that means it's passed through exactly the top of the wall. So this one is 90 degree. This is 35 meter. Then this one is a 10 meter. Okay, so you can see that we have a x. This is the x, this is the y. So we will be using the trajectory equations. So the trajectory equations from the formula booklet, y equals to the x tangent theta minus a g x squared over the 2u squared or square theta from the formula booklet. Okay, so at x equal to 35, y equal to 10, so you have a 10 equals to the x is 35. Tangent theta, you do not know. The g, we can change the g become 10. X is a 35. The u is given as a 24. Then actually we can straight away change the cos square become secant square. So maybe we just write like this. Okay, this one is a secant square. So now if you simplify further, you will get this one as the 6125 divided by 576. This one tangent secant square theta, make it become tangent square theta plus 1. So I just want to make the denominator multiply everyone by 576. Okay. So I will have 615 tangent square theta minus 20160 tangent theta plus the 1185. Then just use your calculator. You can see that your tangent theta is actually equals to the 0.76938. Another value for tangent theta will be 2.5 to 1. Okay, so over here your theta number 1 is a 37.6 degree. Another theta, it will be 68.4 degree. Okay, so this is the answer for the part A. Okay, they are looking for the 2 values of theta. So we have found the 2 values of theta, that's all. Now we move on. Given that the P clears the wall, find the minimum distance from the point O where it can land. Okay, so we have 2 cases. We have a case 1 where the theta is equal to the 37.6, and case 2 where the theta is 68.4 degree. So which one will give you the minimum distance? Which one will give you the minimum distance? You can see that this is a 35 This is the 10 meter. So if you project it with this speed, with this 37.6 degree. Okay. So if you take case 2, the angle is higher. Okay, then it will be 68.4 degree. So obviously, this will give you a shorter distance. Okay, so this will give you the minimum distance. Okay. So for minimum distance, your angle theta must be more than, must be greater. Okay. Okay. So we just say that find the minimum distance from the point O. Okay. So for minimum distance, your tangent theta must equals to the 2.5221. So my theta over here, I will not going to use 38.4 because just now I rounded it up. So to make my calculation more accurate, I will get 68.372 degree. Okay, so I make my angle of projections more significant figure so that I can get more accurate answer. So when the theta is equals to the 68.372, and then your y is a 0 because you landed at the same level, and then we want to look for the x. So your x minimum will equals to, we need to replace it inside here. We need to replace it inside here. I think we need to replace it inside here. Inside here, the x is a 0, the x is a minimum, but the y is a 0. Okay. So again, we just write the trajectory equations. So the 0 is equals to the x tangent theta minus the gx square over the 2u square. And okay, I think we can just write cos square. Okay, so to make our calculation easier, okay, we leave the answer in terms of theta first. We only replace the theta later. So now we can actually factorize the x out. Then we get 10x divided by minus a tangent theta is equals to the 0. X equal to 0 is ignored or rejected. Okay. Then another one is that the x will be equals to the 2 times 24 square cos square 68.372 degree, tangent 68.372 degree divided by 10, this value. So this will be your minimum distance. This will be your minimum distance. So press a calculator, just direct press everything on one shot, then you can get the answer as 39.5 meter. So this will be your minimum distance done. Okay. Now we move on. We have question number 3. Look at question number 3. A round horizontal disc center O rotates with a constant speed of angular speed of omega radian per second. Particle P of mass 1.6 kg lies on a disc at a distance of 1.5 meter from O, and the distance to a point A vertically below O, above O by a light elastic string. So the string is elastic. The string has a natural length of 2 meter, modulus of elasticity 32 Newton, and makes an angle alpha with the vertical OA. Okay. The particle P move in the horizontal circle at a constant angular speed omega radian per second. Particle P on the point of slipping in the directions of OP. the coefficient of frictions between the particle and the disk is 0.5. Okay, oh, so many informations over here. And the first questions, they only want us to show that the sine alpha is a 0.8, given that the tension is 8 Newton. It's not only 2 marks. So you can see that if you look at this triangle, this is the alpha, this is the 1.5. So to get sine alpha is actually 1.5 divided by the hypotenuse over here. So what is the hypotenuse? The hypotenuse is the length of the string that after you have stretched. So what we need to do is to, they already give you the tension, okay? So the T is equal to the lambda x over L, okay? Lambda x over L. So T is given as 8 Newton by Hooke's law. Then lambda is a 32. X you do not know. The L is a natural length. So from here you can see that your X is actually a half. Okay. So which means this hypotenuse length is L plus X. So it's actually 2 plus half. It's a 2.5. Okay, it's a 2.5. Okay. So from here, maybe we can provide a diagram. 1.5. This one is L plus X. This is the alpha. Okay. So sine alpha is equal to the L plus, 1.5 divided by L plus X. Is 1.5 divided by L plus X. Press a calculator, you can get this one as the 3 over 5. Or you can get 0.6 shown. That is the answer for part A. Now we move on to the part B. Find the number of revolution per minute made by the disk and the particle. So over here, to find the revolutions, number of revolution per minute, we need to find the omega, angular speed. So to find the angular speed, we resolve the forces perpendicularly to the plane, vertically. Okay. So over here, maybe I draw a diagram just to show. This is your alpha. Okay, so I think first of all, sine alpha is equal to the 3 over 5 from the right angle triangle here. So you have a 3, you have a 5, then you get a 4 here. Okay, so that's what you need. That is your tension T. This is your mg. This is your R. And this is the O. You are moving these directions, and the point of slipping to the away from the O. So that means that your frictional force, remember that you have a frictional force because the surface is rough. So the frictional force will go this way. Okay, so if you resolve the forces vertically, you have a T cos alpha plus R is equal to the mg. So the T is already known as 8. The cos alpha is a 4 over 5. I do not know the R. The M is a 1.6. G is a 10. So if you go and solve it using calculator, you can get this one as 9.6. That is your first equations. Then if I resolve the forces horizontally, I will have T sine alpha plus the FR is equal to the MR omega square. Okay. So what is the T? What is the sine alpha? 0.6. What is the FR? FR is a mu R. Okay, I forgot to write FR. FR is a mu R. What is a mu? The mu is 0.5. Mu is 0.5. Half. The R is 9.6. So the FR is actually 4.8. So this one is 4.8 equals to the M. R is a radius, 1.5 omega square. Over here, you just need to use your calculator, press everything, you can get your omega is a 2. Okay. Then the number of revolutions per minute. Okay. So we can just write the short form RPM, revolution per minute. By the way, this one is a radian per second. So how do you find the formula for the number of radian revolution per minute? So every second you can rotate 2 radian. So 1 minute you have to multiply this one by 60 seconds. Okay, every second 2 radian, so you have 60 seconds for 1 minute, and then divided by 2 pi. For 1 revolution, the radius is the radian, the total radian is 2 pi. Okay, so simplify it, you get 60 over pi. Then you can give the answer in decimal, 19.1. Done. That is the answer for number 3B. Okay, so now we move on to the question number 4. We have a cone over here. An object is formed by removing the solid hemisphere radius of 2r from a uniform solid cone radius 3r, and the semi-vertical angle theta, the tangent theta is half. Tangent theta is a half. The axis of symmetries of the cone and the hemisphere are coincide. The base of the cone and the base of the hemisphere are in the same plane as each other. See the diagram. Find in terms of r the distance of the cone of the mass of the object from its base. Okay. So over here, we need to know the height of the cone. Okay. So maybe we need the volume of cone. So this is the height. This is the 3r. Okay. So this is the theta. So what you need to do is tangent theta is equal to half. And from the diagram over here, the tangent theta is actually 3r over h. That means your h is actually equal to the 6r. H is actually equal to 6r. Okay. So the volume for the cone is equal to the 1 over 3 by 3r squared. H. Press the calculator, then you can get 18. Okay. Then the volume of a hemisphere is 2 over 3 pi, 2r cubed. So you get 16 over 3 by r cubed. Okay, so these are the things that I need to ready. And before we find the distance of the center of mass from the object from its base. So we need to build the table. Usually I will build the table. So this is the solid. We have a cone here. We have a hemisphere here. We have the total, the remaining object. We can just write down the total object. Okay. So we have a volume here because they are having a same mass. And we are looking for the center of mass from the base. So the volume just now we have calculated, this one is 18 pi r cubed. This one is a 16 over 3 pi r cubed. You minus it, deduct it because you remove the hemisphere. So after you minus it, you'll get this one as 38 over 3 pi r cubed. Center of the mass of the cone, refer to the formula booklet. This one is actually 1 over 4 of the base of the height from the base. So it will be 3 over 2r. Then for hemisphere, it will be 3 over 8 of the radius. Radius is 2r. So you will get 3 over 4r. Then the remaining solid, we do not know the center of the mass, so we put R1. So we just say a moment about the base. Then you just get 18 by r cubed 3 over 2r plus the 16 over 3 by r cubed multiplied by 3 over 4r is equal to the 38 over 3 by r cubed bar y. So by r cubed, by r cubed, by r cubed all can be cancelled. So your bar y is actually equals to the, oh, sorry, I make a mistake here. This is not plus, it's a minus because you remove away the volume. So over here, you just minus it. You will get this one as a 27r minus the 4r divided by 38 over 3. So you will get this one as a 69 over 38r. Done. So this will be the answer for the number 4A. Moving on, we have a B. The object is placed such that its circular base makes an contact with a rough plane, which is inclined to the horizontal at the angle alpha. The object is on the point of top plane. The plane is sufficiently rough to prevent sliding. Find the value of alpha. So we can draw a diagram. Okay, the diagram just for us make it easier to calculate. So this is alpha. Then we have a cone here. The cone, the hemisphere has been removed. The center of the mass is somewhere here, so that it's actually passed through the corner. So my diagram is not so nice. By right, it's supposed to be vertical one. Maybe I try to draw nicer. So try to draw nicer. It will be like this. Okay. So this will be your weight. Center of the mass, vertically go down. Okay. So what you need to do, it will pass through the corner. It will pass through the corner. So this is the alpha as well. Okay. So to find the value of alpha, actually the tangent alpha is actually the base divided by the bar y. Okay. So the 3r divided by, just now the bar y was 69 over 38r. So if you press a calculator, then you can get this as the 38 over 23. Tangent alpha. So your alpha will be 58.8 degrees. Done. So this will be the answer for the question number 4B. Moving on, we have a question number 5. String of natural length 0.5 meter and the modulus of elasticity 14 Newton attached to a fixed point A on a smooth plane. The plane makes an angle alpha to the horizontal where the tangent alpha is equal to the 7 over 24. A particle P of mass 2 kg is attached to the other end of the string. The string lies along the line of the greater slope of the plane. The particle P initially held on the plane above the level of A, where the AB is equal to the 0.8 meter. The particle then released from rest. Find the maximum velocity for the P during the subsequent motion. Okay, so at first, okay, I think we need to write down the tangent alpha first, 7 over 24. Then from the right angle triangle, 7 and 24. Pythagoras theorem, you can get 25. Okay. Then now we draw the actual diagram. You have a fixed point A. So at the beginning, your P is over here. So this, the P is actually is at here, and the distance here is a 0.8. But the natural length is a 0.5. So over here, your extension is a 0.3. Okay, this is the first case. Then after release, then the particle will slide down, and because the surface is smooth, it's a smooth inclined plane. So when the P release, the P will go down, pass through A, and then reach until some point over here in order to get the maximum speed. But this maximum speed, there is a extension over here, which is a x2. You need to find the x2. Okay, so we know that the maximum speed will happen when you just let the A, if you let the B rest, if you let the B rest below the A, if you let the B rest below the A, this is the x2. At this point, when the B slide down at this point where they are in equilibrium, that will be the case where you are having the maximum speed. Okay, so this is something you need to be aware of it. Okay, so we need to consider two cases. One case where the B is above the A. Another case is you let the B go until here. Okay, that is a P. And this is your, we do not know. This will be the 0.5 plus the x2. What is the x2? I do not know. Okay. So what we can do now is at first your EPE initial. At the very beginning is actually equals to the lambda x1 squared over the 2L. What is your lambda? Lambda given as 14. Your x1 is a 0.3. Your A is a half. So this one you can press a calculator. Okay. So this one is 0.3 squared multiplied by 14. You get 1.26. Okay. Now, to get the initial the EPE final, we need to let the, we need to know that they are at rest. Okay, so when you let the T rest equilibrium, below A. So that means that you have a tension here. If you resolve the forces this way, you have a T is equal to the mg sine alpha. So what is your T? T is a lambda x2 divided by L. Okay. What is your L? Lambda? Lambda is a 14. What is your x2? You do not know. What is your L? L is a half. What is the M? The mass is 2 kg. The G is a 10. Sine alpha. Sine alpha refer from here. Sine alpha is a 7 over 35. Okay. So with this, press a calculator, then you can see that your x2 is equal to the 1 over 5. Okay. So now we are considering the motion that you are starting from here and going down to here. You're going down to here, okay? So that means this is the x2, this is the x1. Okay, this is the L, this is the L. Okay, and then we will be having maximum speed over here. We'll be having maximum speed over here. So we need to use conservation of energy. Okay, so by the conservations of energy, we have the GPE loss. I didn't find the EPE final yet. I need to find the EPE final. That means when I reach over here, what is the EPE here? It will be the lambda x2 square over 2L. So it will be the 1.14 and then a 0.2 square divided by 2.5. So this one is 14 multiplied by 0.2 square. Get 0.56. So you can see that the EPE actually lost. Okay, so according to the conservations of energy, your GPE gain, loss, not gain, sorry, GPE loss plus the EPE loss is equal to the KE gain. So it will be the MGH plus the lambda over 2L x1 square minus the x2 square is equal to the half m of the v square minus the u square. Okay. So we just need to we need to find the h. So this is the h. So the h is x1 plus L plus L plus x2. Okay, add all together. Add all together. So you will get, this one is a x1 is a 0.3, L is a 0.5, then the x2 is a 0.2. So add all together. Then sine alpha. Okay. So it will, M is a 2, G is a 10, H is a 0.3 plus a 0.5. I don't need to be so troublesome. We just write 0.8 plus a 0.5 plus a 0.2 sine alpha is plus the lambda. Lambda is a 14 and the L is a half. Then this one is a 0.3 square minus a 0.2 square is equal to the half times 2v square. Okay. So sine alpha, I think sine alpha, we straight away change the sine alpha to become, sine alpha is what? Sine alpha from here, sine alpha is a 7 over 25. So just put 7 over 25. So just press everything with your calculator. You get the v square is equal to 9.1. So your v is the square root of 9.1. You can get the answer 3.02. Done. So this will be the answer for the question number 5. And move on. We have question number 6. Is moving in a straight horizontal line with the speed u. The sphere B is stationary. Sphere A collides directly with B, and then both of them move in the same directions with the speed VA and VB respectively. After the collisions, the KE of the B is 9 over 2 times of the KE of A. Show that the VB is equal to the 6 over 5U. So what you need to do is, okay, maybe we can draw a diagram. So the A is over here, the mass is 2m, the B is over here, the mass is m. So A is moving towards B with the speed of u. Then B is stationary. Then after that, they are moving in the same directions that the VA and VB is the speed after the collisions. Okay, so we are using the principle of conservation of linear momentum. So we just have a 2m u is equal to the 2m VA plus the m VB. Cancel all the m, you get a 2VA plus the VB is equal to the 2U. That will be your first equations. So we know that the KE of A is equal to the 9 over 2 times of the KE of B. Oh, sorry. KE of B is actually 9 over 2 times KE of A after the collisions. So that means it will be half m VB squared is equal to the 9 over 2 multiplied by half 2m VA squared. So you cancel the half, cancel the m, you get a VB squared is equal to the 9 VA squared. So that means your VB is a 3 VA. So that will be your second equations. So now what you need to do is just to solve the simultaneous equations 2 into 1. Then you will get 2 VA plus the 3 VA is equal to the 2U. So your VA is equal to the 2 over 5U. But we are looking for VB. Okay, so from the equation 2, our VB is actually 3 times 2 over 5U is a 6 over 5U shown. So this is the answer for the 6A. Now we move on to the 6B. Sphere B is then collide with the fixed vertical barrier. Immediately before collision, the directions of motions of B makes an angle alpha with the barrier. Immediately after the collision, the directions of the motion B makes an angle beta with the barrier, and the coefficient of restitution between the B and the barrier is 4 over 3. As the result of collision, the velocity of B is reduced to 12 over 25 square root of 5U. Okay. So what we need to do is over here, maybe we can draw a diagram. So this is VB. This is the alpha. This is the beta. Okay, so after the collision, we will just say that this is a WB. Okay. So what you need to do is that if you consider the VB, we write down the VB and WB first. VB, we already know from part A just now, the VB was a 6 over 5U. The WB is given here. Okay, it's given here after the collisions. The velocity is reduced to become 12 5 over 25U. Okay, so this is what we know. So what we need to do now is resolve the velocity horizontally. Okay, so horizontally. So horizontally over here, not really horizontally, parallel to the barrier. Parallel to the barrier, that means no collision is involved. No collision involved, that means your VB cos alpha is equal to the WB cos beta. Okay, so this is what we have. So we write down the VB and the WB. simplify it, cancel the u, then you can get cos alpha is actually equals to the 2 sub 5 over 5 cos beta. Okay, so we can call this one equations 1. Now we consider the one that is perpendicular to the barrier. So this, it will be collision involved over here. So this one we need to consider the Newton experimental law, NEL. So we have the E is equals to the WB, that's a negative here. No need negative. This one is only involve the wall, the barrier with the particle. So WB sine beta over the VB sine alpha. So we already know that the E is a 4 over 5. So we have a 4 over 5 of the VB sine alpha is equals to the 12 sub 5 over 25 U sine beta. Okay, so over here we just need to do the simplifications. You get 24 over 25 U sine alpha is equal to the 12 sub 5 over 25 U sine beta. So the 25 can cancel, the U and the U can cancel. Okay, so at the end you get the sine alpha is equals to the sub 5 over 2. That will be your second equations. We are looking for the sine alpha plus beta. The questions is looking for the value for the sine alpha plus beta. So actually we don't really need to know what is alpha, what is beta. Okay, we just want to know the sine alpha plus beta only. So what we can do is that you just focus on the equation 1. This one I erase. So focus on the equation 1 and equation 2 over here. So we know that equation 1 square plus the equation 2 square, it will give you sine square, it will give you cos square plus sine square. We know that the cos square plus sine square, it will be equal to 1. Then your right hand side, you will expand them. You will get this one as the 4 over 5 cos square B, cos square beta, plus the 5 over 4 sine square beta. So this is a 1. The cos square and sine square, because they are related to the trigonometric identity, you can actually convert either cos square to become 1 minus sine square, or you can convert sine square to become 1 minus cos square. We do it like this. Then we will have a quadratic equations, cos beta in the square form. So if you expand and simplify, you will get this one as the 4 over 5 minus the 5 over 4 cos square beta is plus the 5 over 4. So at the end, you get the cos square beta is actually equals to the cos square beta is actually equals to the 5 over 9. If you use your calculator to simplify them, that will give you cos beta is equal to the sub 5 over 3. Okay, so cos beta is a sub 5 over 3. We can actually build this. Then by Pythagoras theorem, we can have this one as a 2. We can have this one as a 2. Oh, by the way, I need to find the sine alpha as well. I need to find the, I have found the cos beta. Then from the equation 1, I can find the cos alpha. So cos alpha is actually equals to the 2 sub 5 over 5 of the cos beta. So you can actually get the answer is 2 over 3. So cos alpha will give you this. Okay, this one is the 2, this one is the 3, this one is the 35. So you can see that actually the value here all same. It's just that the direction, the location are different. And you can see that that means this is a beta. This is an alpha. So actually we know that from here, from this diagram over here, we actually know that the alpha plus beta is 90 degree. Okay, so from here, we know that the alpha plus beta is actually 90 degree. So therefore, sine alpha plus beta is a 1. Okay, so this is the answer. This is the answer for the question number 6. B. Now move on. We have question number 7. Diagram over here shows a fixed hollow sphere has a radius A and a center O. The point A, B, C lie in the inner surface of the sphere OA and BC horizontal. A portion of the sphere has been removed by the hollow cut through the point B and C at the vertical distance of KA above the center of the sphere, where K is a positive constant where the K less than 1. The point O, A, B, and C all lie in the same vertical plane. AB makes an angle theta with the upward vertical through O. See the diagram. Particle P of mass is freely moved on the smooth inner surface of the sphere. The particle P projected vertically downward from A with the speed U and begins to move in a vertical circle. In the case that the U equal to the 5 over 6, 6 over 5 GA, the reactions of B at B is half of the reactions at A. Find the value K. Okay, so over here, first of all, we are starting from A, then you move to the B. So we will be using the conservations of energy first. Okay, so we start from the conservations of energy. Over here, you can see that from the diagram, you are moving from A to B, you gain the height. So the height is gain. Okay, so the GPE gain, since you have only height and velocity involved, so you have a KE loss, no other external energy involved. Okay, so what is the formula for the GPE gain? MGH is equal to the half M of the U square minus the V square. Okay, so that means the V square is equal to the U square minus 2GH. So the U is already given. So it will be 6 over 5 GA minus the 2G. What is the height? The height is actually KA. This is the height, KA. So we can actually factorize the GA out, make it become 6 over 5 minus 2K. We just leave it here. Okay. Then after that, we are looking for the normal contact force at A. Normal contact force at A, because A is horizontal, you can only resolve the forces towards the center horizontally. So you have the RA is equal to the centripetal force, mu square over A. And your, because your U square is given as a 6 over 5 GA, so we can simplify them to become 6 over 5 mg. That is your RA. Then at B, if you resolve towards the center, you get the RB plus the mg cos theta is equals to the mv square over A. Okay, so but you need to understand the triangle over here. This is the theta, this is the Ka, this is the A. So your cos theta is actually Ka over A. It's actually a K. Okay, so maybe we just write down, draw over here. Theta, Ka, A. So your cos theta is equal to the Ka over A is equal to K. So this one, the RB is actually MA, the V square. We use this result. GA 6/5 minus 2K minus the KMG. Okay, so if you simplify it, you will get 6/5 mg minus the 2 mgk. 2 kmg minus 3 kmg. Okay, so this is the RB. Okay, we need more space. Okay, so since given that the RB is half of the RA, given the RB is equal to the half RA, so we just need to write down 6/5 mg minus the 3 kmg is equal to the 6/5. Three over 5 mg. So you just cancel the mg. So you get the 3/5 is equal to the 3k. Therefore, your k is 1/5. Done. This will be the answer for the 7A, sorry. Okay, so now we move on to the question 7B. Find an expressions for U in terms of A and G in the case that the particle just reaches B. Okay, so if you just reaches the B, okay, that means when you just reaches the B, just means when you reach over here, your V is a 0. Okay, so we just straight away take the equations when the V equal to 0 at B, okay, at B. The V is equal to 0. Okay, so we just need to use these equations. Let the V equal to 0. Oh, but over here cannot because we cannot use this U anymore because this U, just now this U is only for the part A. So for the part B, we have to redo again. For the part B, we need to redo again. So we have a V square equal to the U square minus a 2GH. So the V is a 0. U, you do not know, is no longer square root of 6/5 GA. So your H is K. Your H is height is a KA. But we already know the K is 1/5. So the U square is equal to the 2/5 GA. Therefore, your U is the square root of 2/5 GA. And that is the answer for the B. So now we move on to the C. Find an expressions for U in terms of A and G in the case that the particle passes through B and in the subsequent motion reaches C. So what happened over here is that because the expression for the U that passes through B and in the subsequent motion reaches C, so the B to C, from B to C is actually a projectile motion. It's no longer circular motion, it's a projectile motion. So this is your initial speed. Your initial speed is a V. Your theta over here, the theta over here is same as the theta here. This is the A. So what you need to do is we need to find the V. How much is it? Okay. But just now we know that the V square is equal to the U square minus the 2GH. But this is following from part B. Following from part B, that means the U in part B will be used over here. Okay, the U over here, we will be writing it down as the, oh sorry, I make a mistake. The U is no longer same. The u is no longer same. We need to find the u. Okay. What we need to do is we need to change this h to become Ka, and we know our K is a 1 over 5. So this is what we have at the moment. Okay, so the u is no longer same like just now. Okay, so we have to recalculate again the u. Okay, my apologies on the misdirect just now. Okay, so this is the formula for the v square. Okay, and I will need to square it in, but actually I will just leave it over here first. Don't need to square it first because maybe we do not need to square it later. So this is my initial speed when the B is projected, when the particle is projected from the B and then move to C. Okay, so this is your initial speed. This is your initial speed. For the projections. Okay, then we will be using the trajectory equations. We will be using the trajectory equations. Y equal to the x tangent theta minus the gx square over the 2v square cos square theta. So the v square will be using here. We will be applying the v square over here. But since I will be using tangent theta, so I will need to draw again because just now I know that my cos theta is a k. So if we use the right angle triangle over here, this is the k, this is the 1. This is the k, oh sorry. This is the k. This is the 1. And the k is a 1 over 5. K is a 1 over 5. Then this is if k is a 1 over 5, then this is a 1, this is the 5. This one will be square root of 24. Okay, so we will build this. Now, we will just need to apply them inside here and here. So you will get this equation as y equal to the square root of 24 x minus the gx square over the 2v square. Cos square. Cos square, it will be 1 over 25. Okay. So the things over here looks a little bit messy, but we can just leave it at the moment. Now at this point, when you reach to C, at this point, you will treat this case as a horizontal. So over here, your y is a 0. Because you start from here and you land at the same level, your y is a 0. Then what is my x? My x is the distance over here. So the x, this distance is a sine theta. So you have a 2a sine theta. So x is a 2a sine theta. Okay, 2a sine theta is the same as from the triangle here. So you have a 2 sub 24 over 5a. Okay, then your y is a 0. Okay, so at this coordinate C. Okay, so at C, your x is a 2 sub 24 over 5a. Your y is a 0. So you use these equations. Replace the y becomes 0. Okay, you replace the y becomes 0. Then the x is a 2 sub 24 over 2 sub 24 over the 5a minus the g x square divided by 2 over 25 u square minus the 2 over 5 g8. Okay, so we just need to simplify it. You can get this one as a 48 over 5a is equals to the is equals to the wait this one is a 96 25 GA square divided by the 2 over 25 u square minus the 2 over 5 GA. It looks a little bit complicated. So the A and the A here can be cancelled. The 25 and the 25 here can be cancelled. The 2 and the 2 here can be cancelled. You get 48. The 48 and the 48 can be cancelled over here. So you will get 1 over 5 u square minus a 2 over 5 GA is equals to the GA. So your u square minus a 2 over 5 GA is equal to the 5 GA. So your u square is equal to the 27 over 5 GA. So therefore, your u is equal to the square root over 27 over 5 GA. Done. So this will be the answer for the question number 7C. And this is the last question for this paper. So I'll stop the video here. I'll see you next time. Bye-bye.